Hi, it's Rob. Welcome to another video in the Infrastructure as Code on AWS with Terraform playlist, where we'll implement infrastructure for ECR and ECS. This video is actually the result of a comment posted on the Terraform modules video I had previously created, asking for a module for ECS. So I hope you find this content interesting. Before we jump in, I just want to mention that if you're new to AWS ECR or ECS, you may find a prior video I created which walks you through provisioning this infrastructure using the AWS console interesting. So I'll provide a link to that video in the description below. Now, to get started, currently I have one IAM user configured on my local machine. And this is the only IAM user I currently have in the account. This user is a member of the devs user group, which is the only group I currently have in the account. And the devs user group has the administrator access policy attached. However, I don't want to use this user when working with Terraform. So I'll go ahead and create a new IAM user named Terraform Developer. Which we see has been added. Then I'll go ahead and add the new user to the devs user group. Now I'll create access keys for the new user. And I'll copy these off. And use them to create a new local named profile for my Terraform developer user. And as always, I'll be deleting these credentials after I complete the video. Now let's jump into VS Code and start building our Terraform configuration. To get started, I'll create a main.tf file. I'll add the Terraform block and require the AWS provider. Now I'll create a providers.tf file and paste in my AWS provider block. The next thing I want to do is create a module for the Terraform remote state, which will use S3 and DynamoDB for state locking. So I'll create a new folder, name modules, and inside a new folder, name tfstate. Inside the tfstate folder, I'll create a new file, name tfstate.tf, and add resource blocks for the S3 bucket with versioning and server-side encryption and the DynamoDB table. And looking at this code, we could see we get certain property values such as the bucket name and the table name from variables. So I'll create a variables.tf file and add the variable definitions for the bucket name and the table name. Now I'll jump back over to the main.tf and add a module block for my tfstate, whose source points to the tfstate folder in the modules folder. The bucket name and table name are variables which will be passed into the module, whose values come from local variables. So I'll create a locals.tf file and add the variables and values for the bucket name and table name. Now I'll jump into a terminal, do a Terraform format, then a Terraform init. Now I'll run a Terraform validate, and the configuration's valid. So now I'll do a Terraform plan. And we see the plan is to add 4 resources: the DynamoDB table, the S3 bucket, with server-side encryption and bucket versioning. So now I'll go ahead and apply the configuration. And the 4 resources have been added. Here we see our S3 bucket and our DynamoDB table. Now I'll jump back into VS Code into the main TF and add a backend block for S3. Then I'll go back to the terminal and run a Terraform init. I'll say yes to copy the existing state to the new backend. And the new backend has been configured in S3. Okay, with our base Terraform configuration and AWS infrastructure in place, we can move on and start creating our modules for ECR in ECS. So to begin with, in the modules folder, I'll create a new folder named ECR, and inside a new file named ECR.tf. Here I'll add a resource block for an AWS ECR repository and set its name property equal to a variable which will be passed in. So I'll create a variables.tf file, add the variable definition, and while I'm here, I'll add an outputs.tf file and add an output block for the repository's URL, which will be sent to the ECS module as a variable. Now I'll jump back over into the main TF and add a module block for the ECR repo pointing to the ECR folder and the modules folder, and I'll pass the ECR repo name as a variable whose value will come from a local variable. So now I'll jump into the locals.tf and add the variable and value for the ECR repo name. Now I'll go back to the terminal, run a Terraform init to pick up the new module, do a Terraform validate, then a Terraform plan. Here we see we have one resource to add, which is our ECR repo. And now I'll go ahead and apply the plan. And our ECR repo has been added. And if we jump into the AWS ECR console, we see our repository has been added. But it doesn't yet have any images. So let's jump back into VS Code and take a look at the application which will be publishing to this repository as a Docker image. Inside of our root project folder, I've added a new folder named app. And inside, there's a Docker file and a source folder. In the source folder, there's a server.js file, which is a simple Node.js application, which when we access the contacts route on port 3000, will return this hard-coded list of contacts. Inside the package.json file, we see I've included one dependency for Express. Now, taking a look at the Docker file, we see I'm including the base image from Node Alpine, setting the workdir to the source folder, then copying the package.json file to the workdir, and then running npm install to install the dependencies. Then I'll copy the source folder and declare that I want to expose port 3000 on the container. And finally, I'll run the node command, passing it the server.js file. And now, just as a demo to test the app, inside of the app source folder, I'll run an npm install, then start the server. Now I'll jump back into the other terminal and curl localhost on port 3000, hitting the contacts route. And here we see our JSON was returned. Now it's time to take this Docker file and use it to create a Docker image of this application, which we can push to our ECR repository. And to do that, I'll jump back over to the ECR console and click the View Push Commands button. And these are the commands that we'll need to run in order to log into ECR, build the Docker image, tag it, and then push it to the repo. So I'll start out by copying the first command and jumping back into the terminal and pasting it in. Now, I did make one modification to this command, and that's to add my Terraform developer profile when executing the AWS ECR command. Okay, so now I've successfully logged into ECR, and now I'll jump back over and grab the next command to build the image. And I do want to note that because I'm running on an M1 Mac, I also need to pass the platform. Oh, and it might help if I'm in the folder with the Docker file. So I'll change into the app directory. And there's the Docker file. So now I'll go ahead and execute that Docker build command again. All right, and with that complete, I'll jump back over to the ECR commands, copy the command to tag the image, execute that, then grab the final command to push the image to the ECR repo. Now with the image pushed, if we jump back over to the ECR console and refresh, we'll see our image with the latest tag in our ECR repository. So now we could jump back over to VS Code and start building out the module for ECS. To get started, in the modules folder, I'll create a new folder for our ECS module, then create a new ECS.tf file. I'll start out by adding a resource block for an AWS ECS cluster, whose name will come from a variable, and then I'll add a resource block to deploy the cluster in the default VPC. Then I'll add resource blocks for 3 subnets whose availability zone properties, whose availability zone values will be set by variables which are passed in. Next, I'll add a resource block for the ECS task definition, passing the task family in as a variable, and then defining the container definition inside of this definition block. The name will be passed in as a variable, as will the image, which is the URL to the ECR repository. The container port and host port will also be passed in as a variable, and I've added values for additional variables to define the task definition. Here I'll create a resource for an AWS IAM role, passing its name in as a variable, and then setting the assume role policy property equal to a value which will come from a data block. So I'll go ahead and create a data.tf file and add a data block for an AWS IAM policy document, which allows the STS assume role action for the ECS task principal. Next, I'll add the resource block for the AWS IAM role policy attachment, which will get its role property from the ECS task execution role's name created above. Next, I'll add a resource for an application load balancer, passing its name property in as a variable, and setting its subnets equal to the default subnets we created above. The security groups will be set by referencing an AWS security group resource named Load Balancer Security Group, which I'll define here. This security group will have an ingress on port 80 over TCP and a wide open egress. Next, I'll add a resource for a load balancer target group, passing its name and port values in as variables and setting the VPC ID equal to the default VPC's ID. Here, I'll create a load balancer listener and attach it to the ARN of the application load balancer resource created above, and setting its target group equal to the ARN of the target group created above. Now I'll create the resource for the AWS ECS service, setting its name equal to a variable which will pass in, its cluster equal to the demo app cluster which we created above, and grabbing its ID property, and the task definition equal to the ARN of the demo app task created above. The load balancer for the ECS service will get its target group ARN property from the ARN of the target group created above. Its container name will come from the demo app task created above, grabbing the family property, and the container port will be passed in as a variable. The network configuration for the service will set its subnets equal to the default subnets created above, and the security groups will be equal to the service security group resource which I'll create below, and grabbing its ID property. And finally, I'll create an AWS security group resource, setting the ingress security groups property equal to the security group ID for the load balancer security group created above, and give it an egress that's wide open. Now I'll go ahead and save the file and create a variables.tf file and paste in the variable declarations for the ECS module. Now I'll jump back over to the main TF file and add the module block for the ECS module. The variables that we'll pass in will come from local variables declared in the locals.tf file, and the ECR repo URL variable will be populated by accessing the module block declared above named ECR repo and grabbing the repository URL, which is accessible via the outputs file in the ECR module. Now I'll jump into the locals.tf and add the variables for the ECS module. Now, for the most part, the values of these variables are trivial. However, I want to point out the container port, which has a value of 3000. Now, that's obviously the port that we want to expose on the container. And if we jump back into the app folder and go into the source folder and open up the server, we'll see that the app is listening on port 3000. And if we look at the Docker file, here we've declared that we want to expose port 3000. And the value of the container port, if we jump back into the ECS module and search for it, we'll see that it's used in the port mappings for the ECS task definition, as well as the port in the load balancer target group and the load balancer container port. So it's important to remember to set this variable's value equal to the port that your app is running on and that you're exposing from the container. Now I'll save the file, jump back into the terminal, do a Terraform format, a Terraform init to pick up the new module, a Terraform validate, a Terraform plan, and a Terraform apply. And after just under 2.5 minutes, our apply is complete with 14 resources added. So if we jump into the AWS console and jump into the ECS dashboard, we see our cluster with one task running. Then if we jump over to the EC2 management console and go into our load balancer, we could copy the DNS name, jump into a browser tab, paste it in, and hit the contacts route, and we see our JSON data being served. Now, the last thing I'll do before we wrap up the video is to run a Terraform destroy to clean up our resources. So that concludes this video on provisioning AWS ECR and ECS infrastructure using Terraform. I hope you found it useful.